So, as you all know, 3I Atlas successfully passed Mars and is now rapidly moving toward the Sun. This is currently the most intense phase of interstellar travel, spreading water much further from the Sun than expected. Its tail seems to be vying for the title of the most interesting comet of the year, full of carbon dioxide. Clearly, this visitor didn't come from here. Once it reached perihelion, astronomers began pointing their telescopes at it, observing what would happen as sunlight and radiation increased. So, my main goal in this video is to explain these new discoveries and highlight their significance, as well as to describe the possible future behavior of this crazy space traveler. The point is, the story of 3I Atlas began in July 2025, when astronomers in Hawaii, using their Atlas research, detected a small object moving much faster than normal due to gravity. Looking at its hyperbolic orbit, we confirmed our third interstellar visitor after Oumuamua in 2017 and Tui Borisov in 2019. Let's fast forward. In early October, it passed Mars orbit, and Europe's ExoMars Trace Gas Orbiter took a spectacular photo from afar. There was no visible tail, only a bright and dense coma, indicating that this comet would not typically produce a tail. On the other hand, ground-based telescopes and the James Webb Space Telescope teamed up for a detailed examination. While still 2.9 astronomical units from the Sun, they discovered 3 atlases acting like an overactive space humidifier, ejecting about 40 kilograms of water vapor per second. This caused great excitement, and a bit too early. And carbon dioxide. The water ratio was entirely different compared to most comets. While generally, water dominates in many comets, 3I Atlas appears to be rich in carbon dioxide. Basically, a comet that's like soda in the universe. Polarimetric observations also support this, and the light from its dust shows that it either comes from fine grains or has an unusual chemical composition. Furthermore, older data from a transiting exoplanet survey satellite reveals it was already active 6 astronomical units from the Sun. That's a distance far enough from the Sun that many comets are still dormant and deny its presence. Such early activity is quite rare. This suggests that 3I Atlas formed in a much colder and chemically unusual environment than our local atmosphere, a completely different star system with its own rules, its own vibrations, and possibly its own unique recipe for cometary water. While this excites scientists, it's also perhaps a little confusing. Usually, water ice doesn't sublimate until a comet comes closer than 3 astronomical units. That's why most comets go dormant until they reach their orbits in the inner solar system. But 3I Atlas defied that. It decided to wake up early and cause trouble. The strongest current theory is that supervolatile chemicals like carbon dioxide or carbon monoxide are lurking just below the surface. These substances are so sensitive that even the slight warmth of deep space can trigger their explosions. This pressure may have caused the crust to crack, allowing gas and eventually water to escape first. Another possibility is that its core exhibits a fragmented, chaotic, porous, or fractured structure, allowing sunlight to penetrate deep within and heat everything up faster. Regardless of why, one thing is certain. The 3-eyed Atlas offers a rare insight into the composition of comets in other solar systems. This is quite different from what we are used to. A carbon dioxide-dominated comet like the 3-eyed Atlas points to a significant situation. This asteroid formed in the freezing edges of a distant protoplanetary disk, not in the warmer regions where our own comets typically form. Its interstellar orbit further supports this, making it a cosmic representative of a tourist with a rather peculiar passport. Even the concept of polarization, how dust scatters polarized light, doesn't align with the cues observed in local comets. This suggests that the dust particles may have a different structure or size, or be composed of minerals we're not accustomed to here. Furthermore, because dust particles essentially carry the chemical signatures of their host systems, scientists can understand the nature of the environment in which this formed. Yes, there are always the maybe aliens claims, greetings to Avi Loeb, but in this case, everything points to a completely natural source. We're talking about a highly variable, chemically diverse snowball forming around a distant star. An apology to science fiction enthusiasts for now. Oumuamua and the Tui Borisovs have already been inducted into the Hall of Fame, but 3I Atlas is the third registered interstellar guest, making these objects rare VIP guests at solar system events. Each one helps us understand how planets and comets form, not just in our immediate vicinity, but across the galaxy. Now for the exciting part. On October 29th, 3E Atlas will make its closest approach to the Sun, at a distance of 0.53 astronomical units. This is a very critical moment. Astronomers are preparing because there are 3 possible outcomes. First, a massive explosion. It could suddenly create an impressive tail, displaying a dazzling cosmic fury. Second, disintegration. It could crack due to overheating. Third, a smooth passage. It could pass by the sun as if nothing happened. That's the least expected scenario. But whatever happens, comets love surprises. What happens after perihelion will be crucial. That's when we get the best data and hopefully be able to unravel the mysteries of this interstellar visitor. The European spacecraft, JUICE, not a breakfast drink, is currently behind the sun and is perfectly positioned to monitor developments after perihelion. The only drawback is that it will be using its slower backup antenna, so scientific updates will arrive late, perhaps in early 2026. It seems the spacecraft are also experiencing communication problems. Here at home, the James Webb Space Telescope, Hubble, and various ground-based telescopes will be tracking this event in near real time, observing every detail. The change in the coma encompasses all the chemical shifts and shocking explosions that could occur if the three atlases were to experience a sudden burst. If it successfully avoids its humming close pass with the sun, it will reappear in our sky in early December, gliding 270 million kilometers from Earth. No need to panic. This is somewhere on the other side of town, on the map of the galaxy. This return offers researchers the opportunity to make before and after comparisons. How does the sun's heat alter matter occurring around an entirely different star? This is the kind of experiment that cannot be done in laboratories. Moreover, the risks from this single visitor are greater. Along with the three-eye atlases, Oumuamua, Imua, and the two-eye Borisovs, they help us understand how we have debris between interstellar states and how planet formation can differ across the galaxy. These cosmic travelers can offer insights into how planets form, evolve, and sometimes eject debris at us. In addition, each interstellar detection helps scientists develop better early warning systems. This means that mysterious things will resurface. When a new object enters our solar system, we will quickly get our telescopes ready for use. When one of these interstellar visitors passes by, we get more information about their number, composition, and how they react to the sun's heat. As our detection technology improves, we may be ready to study future cosmic visitors, taking them into account. Perhaps we can even send a special spacecraft to meet one, perhaps even catching it. The three Atlas comets are very different from all the comets we have seen so far, because of their strange chemistry and very early activity, like a flying clue from a completely different star system. The upcoming moment at perihelion is not only an exciting event. This situation could have significant implications for how we will search for interstellar objects in the years to come.